Okay, in this lesson we're going to look at three things. We're going to look at functions, function notation, and then domain and range. So let's start by reviewing some concepts that you know from before. And so the first question asks us to evaluate y equals negative 3x minus 2 when x is equal to 5. So it tells you what the value of x is. All we need to do is substitute it into the equation that we have here to solve for y. So we have y equals negative 3 times 5 minus 2, and if we simplify this, negative 3 times 5 is negative 15, minus 2 is negative 17. Now if you look at the way this is written, this looks like a linear relation, and so if we know an x-coordinate, then we can solve for the y-coordinate, which is what we did here. And so what this tells me is that 5 and negative 17 is a point on the graph of this line. Okay, so keep that in mind. We are going to come back to something similar to this in a few minutes. Okay, second question just asks us to sketch the graph of y equals 2, x minus 3 squared plus 1. You'll notice that because there's an exponent of 2, this is a quadratic relation. So if I graph this, I need to know a few things. I'm just sketching the graph, so I don't need to use the step pattern. I just need to use the transformations to help me plot the vertex and then go from there. So let's take a look at what the vertex is. In this case, this looks like a shift to the right 3 and a shift up 1. So that tells me that the vertex would be at 3 and 1. So I'm just going to create a scale quickly. And my vertex is at 3 and 1. Okay? Now looking at the value of a, this tells me whether the graph is going to open up or down and whether it's narrow or wide. And based on the value that we have here, this is a vertical stretch by a factor of 2. So I know that the graph is going to be narrow and it's going to open up. And there is the graph of y equals 2, x minus 3 squared plus 1. Okay, so keep that in mind also because we are going to be referring back to this graph later on. Okay, so just a review of some of the terms that you learned yesterday. First of all, an expression is a combination of numbers, variables, operators, and grouping symbols such as brackets, which can be evaluated. So you'll notice that it's just a bunch of terms. You can also have something that looks like this. This is also an expression. You'll notice that this one has a set of brackets in it. Okay, an equation is a mathematical statement where two expressions are set equal to each other. An equation is only true for specific values of the variables. So here's an example of an equation. This equation is only true for specific values of x. Okay, so there's only a couple of values of x that will actually make the left side here equal to 0. Okay, here's another example of an equation. So I took the expression that I had above and I set it equal to a number, and now this becomes an equation. Now there's only a specific value of x that will ever make this equation true. Okay, a function, this is the one we're going to focus on today. A function expresses dependence between two quantities. A relation is a function if, for every value of x, there's only one unique value of y. Okay, that's what we're going to be looking at. First of all, in a function, you'll see that there's dependence between two variables. Okay, so you have y equals 3x squared minus 5x minus 2. What that means is y can be solved for if you know what the value of x is. As soon as you plug in the value of x into this function, you can solve for the corresponding value of y. Okay, this is also a function because as you plug in a specific value of x, there's only one value of y that you will get as a result for that particular value of x. Okay, that's what makes it a function. We'll talk more about that in a couple of minutes. Okay, relation. So this is some more terminology just to help you see the difference between what a relation is, since you saw that last year, and what a function is. So a relation is a set of ordered pairs. So it's really any relationship between two variables. Okay, they don't have to have any particular graph that represents it. So for example, it doesn't necessarily have to be a linear relation, it doesn't have to be a quadratic relation. It could just be a scatter plot even. That still shows a relationship where it shows that there's no relationship. As long as a relation has a set of ordered pairs, it's called a relation. Okay? A function is a very special type of relation. You're going to see this word throughout the semester. The special part of a function is that for every value of x, there's only one unique value of y. Okay, so each x has one specific value of y that corresponds to it. Okay, you can't have multiple values of y for a particular value of x. So here's an example here. It says, is the following relation a function? So if we just look at the table, we hide the rest of this. If we just look at the table here, you'll notice that we have a relation right now, and we want to see whether or not this is a special type of relation, and that special type of relation is a function. So what we're looking to see is, if I look at a particular value of x, is there more than one value of y that corresponds to it? If there is more than one value of y that corresponds to that value of x, then it is not a function. So, for example, if I look at x equals to 2, I have more than one value of y that corresponds to it. At x equal to 2, I have y equals 5 and y equals negative 3. Now, that particular problem that we have makes it not a function. Okay? Each x value should have one value of y that corresponds to it. This value of x has more than one value of y that corresponds to it. That's what makes it not a function. Whereas all the other values of x are only with one value of y. Okay? So the fact that this value of x equal to 2 has more than one value of y, that's what makes it not a function. Okay? So for the same value of x, there are two different values for y. There's a graph of it. What you'll notice is that at x equal to 2, you have multiple values of y. Okay? So for example, if I ask you what the y value is when x is equal to negative 1, you should be able to look at the graph and be like, okay, there's only one value. But if I ask you what the value of y is when x is equal to 2, there's way too many values. There should only ever be one value in order for it to be a function. If there's more than one value, then it's not a function. Okay, if you do have a graph of a relation, so when the relationship is graphed, we can use the vertical line test to determine whether or not the relation is a function. Okay, so here's two more examples just to help you see how to do this graphically. And so what you would do is you would take a vertical line. This is how you would test to see whether or not it's a function. You would take a vertical line and you would go across. And if this vertical line hits the graph more than once, then that means it's not a function. If it hits it only once in each place, then it is a function. Okay, so this example is a function. It passes the vertical line test, which means for every value of x, there was only one unique value of y. Okay, let's take a look at the next example. Again, it's graphed, so I'm going to use the vertical line test. And as I take this vertical line across, you'll notice immediately that the graph is hitting the vertical line in more than one place. Okay? If I continue to go across, it's still doing that. The only places where it won't hit it in more than one place is right at the end. Okay? So right at the beginning and right at the end. But it doesn't matter. As soon as a graph is hit in more than one place, then it automatically makes it not a function. Okay? It does not pass the vertical line test. For some values of x, there are multiple values of y. Okay, let's take a look at some examples that we're going to do by hand. And so you'll notice that these examples, you're either going to be given a set of points. And this is just another way of writing a set of points. This is called set notation. It's the same idea as making a table of values. So if I wanted to use a table of values, it would look like that. And so this just represents a bunch of points that I have in a table of values. It's just a different way of writing them. Okay? So it's not a big deal. It's just a set of points instead of a list of x and y coordinates. Okay? So in example 1, we're going to determine if each relation is a function. And so what we want to see is if any particular value of x has more than one value of y. Okay? So let's look at each of the values of x that we have here. And we want to see if the value of x is repeated, and if it is repeated, if the values of y that are corresponding to it are different. Okay? So here I have x equal to 1. I only have x equal to 1 in one place, which means there's only one point that corresponds to x equal to 1. Okay? And so that means that x equal to 1 is fine. Let's take a look at x equal to 2. Again, x equals 2 is not repeated, so that means that there's probably only going to be one point that corresponds to it. X equal to 3, again, not repeated, and x equal to 4 is not repeated. And if you look at it in the table of values, you'll notice that each x value has a unique y value that corresponds to it. There's no repetition of x values, and so this would make it a function. Okay, each x value has a unique y value. Okay, the second example that we have, We have 2 and 7 as our first point, 3 and 8 as our second point, 3 and 9 as our third point, and then 4 and 0 as our last point. Again, we're going to look at the x-coordinates, and we're going to try to see whether or not there's only one unique value of y that corresponds to it. So looking at x equal to 2, it only appears once, which means there's only going to be 1 point when x is equal to 2. There's only one y value that corresponds to it. At x equal to 3, I have y is equal to 8. But at x equal to 3 again, I have y equal to 9. So this part here tells me right away that this will not be a function. Okay? X equal to 3 has multiple values of y that correspond to it. Okay? Remember that for a function, each x value should have one unique value of y that corresponds to it. Okay? So each x should have one y. Okay? This x has more than one y. Okay? So this one is not a function. And that's because x equals 3 has multiple values of y. Corresponding to it. Okay, so we have y equals 8 and we have y equals 9. Okay, here's a couple more examples. These ones are graphs, and so what that means is I can use my vertical line test to help me determine whether or not this is a function. And so here's my vertical line, and this is a circle. Some of you guys might be able to tell whether or not it's a function just by looking at it at this point. So if I move the vertical line across, what do you notice? It crosses it in more than one place. So it doesn't matter whether it crosses in more than one place just once, or if it does it a multiple number of times. This makes it not a function because it does not pass the vertical line test, which means for many of the values of x that we have here, there are multiple values of y. So this one is not a function. And that's because it's not just one value of x that has multiple values of y, it's a bunch of values of x that have multiple values of y. Okay? So each x value does not have a unique y value. Okay, let's take a look at the last one here and see whether or not this one's a function. Again, do the vertical line test, see if it passes the vertical line test. And so far it's only hit the graph in one place all the way across. So what that tells me is that this is a function. Okay, each x value has a unique y value. Okay, so each x value has a unique y value. So what does that really mean? That means if I choose a value of x on this graph, the value of y that corresponds, there's only one value of y that corresponds to it. So if I say, what's the value of y when x is equal to 3? Negative 3, you'll say that y is equal to negative 3 as well. Okay? You won't have to hesitate to think, okay, how many values of y correspond? Okay? Whereas here, if I said, if x is equal to 2, what's the value of y? You would say 7. And if I say x is equal to 3, what's the value of y? You won't be able to decide between 8 and 9, because now that means that there's too many values. That's what makes it not a function.